Division of complex numbers in polar form follows a simple procedure similar to multiplication. Learn it here in Mathematics of Engineering. A complex numbers form is 1 with r multiplied by cosine of theta plus I sine of theta. Again, r is called the modulus or absolute value, which means that r is always a positive number. Theta is known as argument. How do we divide complex numbers in polar form? We divide the moduli and subtract the arguments. We divide 6 cosine of 40 degrees plus I sine of 40 degrees by the other complex number 3 cosine of 35 degrees plus I sine of 35 degrees. All we need to do is to identify the parts of each complex number. Z1 has a modulus of 6 and argument of 40 degrees. The second complex number has r of 3 and theta of 35 degrees. Knowing these pairs of parameters, we can divide r1 with r2. That is 6 divided by 3, which is 2. Theta is solved as theta 1 minus theta 2. That is 40 less 35 degrees, giving 5. The resulting complex number is then 2 times cosine of 5 degrees plus I sine of 5 degrees. The second example has the first complex number as 9 cosine of 120 plus I sine of 120 degrees. The divisor is another complex number which is equal to 4 cosine of 45 plus I sine of 45 degrees. From the first complex number, the modulus is seen as 9 and theta is 120 degrees. We also take r as 4 and theta as 45 degrees from the second complex number. Divide r1 by r2, and that is 9/4. Theta is then from theta 1 minus theta 2, that is 120 minus 45 to have 75 degrees. So the quotient of the complex numbers is 9/4 of cosine 75 plus I sine of 75 degrees. The procedure still is followed even when theta is given in radians. Say we have z1 as root of 2 cis pi over 4 and z2 is 2 root of 2 times cis of 3 pi over 8. z1 is taken as root of 2 times cosine of pi over 4 plus I sine of pi fourths. So r is root of 2 and theta is pi over 4. z2 is 2 root of 2 times cosine of 3/8 of pi plus I sine of 3/8 of pi, where r is 2 root of 2 and theta is 3/8 of pi. R is then root of 2 divided by 2 root of 2, which is simplified as 1/2. Theta is also pi over 4 minus 3/8 of pi. With different denominators, we take the LCD and make equivalent fractions. So pi over 4 becomes 2 pi over 8. Solve this as 2 pi over 8 minus 3 pi over 8, which turns to be negative pi over 8. Thus, the quotient is half of cosine of negative pi over 8 plus I sine of negative pi over 8. With z1 as 6 cosine of 3/4 pi plus I sine of 3/4 of pi, and z2 as 2 root of 3 cosine of 3/8 pi plus I sine of 3/8 pi, we again take the quotient. The first complex number has a modulus of 6, and an argument of 3/4 of pi. The second complex number has an r of 2 root of 3 and theta as 3/8 of pi. So the resulting r is 6 over 2 root of 3, giving 3 over 3 root of 3. The answer has a radicand in the denominator, which isn't allowed. So rationalize by multiplying root of 3 and making r as 3 root of 3 over 3. Simplify the fraction into root of 3. Theta is 3/4 of pi minus 3/8 of pi. Make similar denominators with LCD and transform the first theta into 6/8 of pi. So 6 pi minus 3 pi makes 3 pi over 8. The quotient then turns into root of 3 times cosine of 3/8 pi plus I sine of 3/8 of pi. Another example has the first complex number as 4 cosine of 5 pi over 4 plus I sine of 5 pi over 4. The second complex number has root of 2 times cosine of half of pi plus I sine of pi over 2. From the first complex number, r is seen as 4, and theta is 5/4 of pi. From the second complex number, the absolute value is root of 2, and the argument is half of pi. The modulus of the resulting complex number is then solved as r1 over r2, and that is 4 over root of 2. Rationalize to eliminate the radicand in the denominator, and get 4 root of 2 over 2. This is then simplified as 2 root of 2. Theta is solved as 5/4 of pi minus half of pi. Pi over 2 is transformed as 2 pi over 4. So theta is 3 pi over 4. The quotient is then 2 root of 2 CIS of 3/4 of pi. The other pair of complex numbers has z1 as 3 cosine of 5 pi over 6 plus I sine of 5 pi over 6, where r is 3 and theta is 5/6 of pi. From the dividing complex number, r is root of 3 and theta is 1/3 of pi. The resulting modulus is then 3 over root of 3. Rationalize it and get 3 root of 3 over 3, simplified as just root of 3. Theta is then the difference of the two thetas, that is 5/6 of pi minus 1/3 of pi. By LCD, the second theta would be equivalent to 2 pi over 6. So 5 pi minus 2 pi becomes 3 pi over 6, reduced to pi over 2. Therefore, the quotient of the complex numbers is root of 3 CIS half of pi.